quadratic equation is an equation that has an x squared term. It may also have an x term, and it may also have a constant term. Some examples: x squared minus 9 equals 0. X squared plus 9x equals 0. Minus 2x squared plus 3x plus 4 equals 0. X squared equals x plus 1 are all examples of quadratic equations. All of these equations have an x squared term. How do we solve quadratic equations? In other words, how do we find the solutions of quadratic equations? Let's start with a few examples where we can spot the solutions easily. For example, x squared equals 1. Remember, a solution is any number that makes this equation true. So a value of x that makes the statement x squared equals 1 true. Well, we can certainly say that 1 is the solution, because 1 squared is 1. That's true. So we can say that x equals 1. 1 is a solution of this equation. But minus 1 is also a solution of the equation x squared equals 1, because if we replace the x with minus 1, it makes the equation true, because minus 1 squared is 1. So minus 1 is a solution of the equation. So 1 and minus 1 are the only numbers whose squares are equal to 1. So the equation x squared equals 1 has two solutions, namely 1 and minus 1. These are the only two values of x that make this equation true. Another way of saying this is, if x squared equals 1, then x is equal to plus or minus 1. So this symbol here is shorthand for plus or minus. So we could write it as x equals plus 1 or minus 1. This is just a shorthand way of saying this. So we found out that some quadratic equations have two different solutions. So this is different from linear equations, which only have one solution. Another example, this time the variable is t, so t squared minus 25 equals 0. So we can solve this one as follows. First thing we're going to do is we're going to move the 25 to the other side. So this becomes t squared equals 25. So a solution to this equation would be a number whose square is 25. Well, the square root of 25 will certainly work. The square root of 25 is 5. So 5 is the solution of this equation. But minus 5 will also work, because minus 5 squared equals 25. So again we have two solutions. The solutions are minus 5 and plus 5. So we can say that if t squared equals 25, then t is plus or minus 5. Sometimes we use the word root instead of solution. So we can say minus 5 and plus 5 are the roots of the equation t squared minus 25 equals 0. So far so good. But what about a quadratic equation with an x term? Like x squared minus 5x plus 6 equals 0. So we've got this x term. It's not so easy to see how to isolate the variable in this case. It turns out that 2 is the solution of this equation, because 2 squared minus 5 times 2 plus 6 is equal to 4 minus 10 plus 6, which is equal to minus 6 plus 6, which is equal to 0. So 2 is a solution of this equation. 2 is a value that makes this equation true. It turns out that 3 is also a solution, because 3 squared minus 5 times 3 plus 6 is equal to 9 minus 15 plus 6, which is equal to 9 minus 15 is minus 6 plus 6, which is equal to 0. So 3 is a solution of this equation. 3 is a value that makes the equation true. So we've discovered that 2 and 3 are the roots, also known as solutions, of the equation x squared minus 5x plus 6 equals 0. But if we didn't know what the solutions are, how would we find them? The x term complicates the situation. In a later lesson, we will see how to deal with this. Thanks for watching. Talk to you in the next lesson.